Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Resin, the online editor for Bioprocess International. And before we get started, I'd like to just give you a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion because this is, after all, Ask the Expert. And I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. Thank you for joining us today. It is now my pleasure to introduce Dr. Kiran Chodavarapu.
Thank you, Leah. I'd like to welcome everyone as well to the webinar on a new incompressible resin to improve downstream productivity. I'm excited to share some of the chemistry that went behind the development of our Protein A product. I thought we'd start with discussing what is Provence Protein A. The Provence Protein A is a high-capacity resin that offers similar selectivity to some of the leading benchmarks in the industry. It's fundamentally an incompressible resin, allowing our customers to leverage the high-flow capabilities of the resin itself. By bringing together a high-flow, high-capacity resin with a truly disposable technology, we're now able to offer solutions for the single-use facilities across the world. So in this discussion, we're first going to explore the science that went behind the development of the product. We're going to follow that by a case study that quantifies the cost impact looking at a phase 1 GMP run. The secret to the sauce really lies in the silica technology itself. Grace has been a manufacturer and developer of silica for over 50 years and has supplied these products to a variety of industries, from food to biopharma. The silica manufacturing is spread across 4 facilities across the world, one of which you can see right there is in Worms, Germany. In the world of bioprocessing, we specifically focused on optimizing a silica that would meet the performance characteristics to help our customers drive productivity out of their facilities. The attributes that helped achieve these objectives are shown on the bottom right-hand side. Basically, a 70-micron particle with approximately 30 meters square per gram surface area and a pore diameter around 1,250 angstroms, with a recombinant protein A from Repligen. On the next slide, we will explore the rationale that went behind the development of these attributes. So in this slide, you can see the 3 key performance characteristics that we drove towards in our product development. Our primary focus was around maximum binding capacity. To achieve this, our objective was to deliver a product that had the maximum surface area to increase the interactions between protein A and the IgGs. Our objective was to develop a product that also would offer minimum steric hindrance and diffusion limitations by optimizing the particle size and pore size appropriately. The net result was a product that delivered between 10 to 15% higher binding capacity than some of the competitive benchmarks. Our other goal was also to deliver a product that offered comparable selectivity, and this was done by deploying some unique surface technology modification from Grace onto the surface of the silica itself. The result was a product that basically delivered similar high molecular weight proteins and other selectivity characteristics that our customers are concerned about. On the final element that we delivered on was a low back pressure, high flow capable resin. By leveraging our rigid silica beads, we were able to develop a product that basically would offer a linear relationship between flow rate velocity and back pressure. This ensured that the product was completely scalable regardless of column size and flow rates. On the next slide, we'll then look at how these things would impact our product performance. Before we get there, we would like to get a quick survey from the audience of your experience with silica-based protein A resins. If you could take a moment to fill out the survey. Thank you. So In this next slide, we will take a look at how the scalable resin was then complemented with a scalable disposable column hardware. This came through our collaboration with Repligen, leveraging their Opus hardware, which has column dimensions that extend from preclinical all the way to manufacturing. These columns are made with Class 6 compliant materials and are provided with regulatory support valves to help our customer adoption. The dimensions allow complete scale from preclinical, where the objectives might be to accelerate proof of concept, all the way to manufacturing to help deliver on productivity and cost control objectives. By packaging the pre-packed hardware with our silica-based resin, we're able to then help our customers accelerate their drug development objectives. So in this next two slides, we will take a very quick look at the cost impact associated to using Provance Protein A. This specific scenario evaluated a customer situation who was trying to drive an objective of reducing their purification time. The primary goal was to reduce the time in the purification suite to increase the productivity out of their plant. This was done with a 1,000-liter bioreactor at a 2 gram per liter titers. The traditional process involved a 4-cycle self-packed multi-use column. The process would involve a 13-liter traditional agarose resin that would be packed, followed by clean-in-place steps, along with validation and storage. In order to drive the time reduction, we provided an alternative to going to a larger column, a 24-liter pre-packed disposable column. This allowed us to reduce the number of cycles, but also at the end of the campaign, be able to dispose of the column itself. In this process, we're now able to offer the customer an option to drive down substantially their purification time. If you look at the purification time, using a 4-cycle process was essentially 145 hours. By eliminating packing and by reducing the cycles, we were able to drive down with a high-efficiency, high-capacity resin down to a 27-hour purification time. This was an 81% reduction in the purification time itself. However, this substantial reduction in purification time did not come at a higher cost. In fact, we were able to also deliver a 35% reduction in just the column costs. This includes column hardware and resin. Additionally, we were able to offer this with a 40% reduction in the total cost of operations, taking a process from $600,000 down to a $370,000 total cost of operation. All of this also comes with a pre-packed disposable hardware that then ensures that our customers can preserve the integrity of their product and avoid any cross-contamination. In summary, I would like to get another survey. I'd like to get your thoughts on how many cycles do you typically get out of your Protein A GMP columns. Thank you very much. In summary, using Provance Protein A can help our customers improve productivity out of their facilities. We looked at how Protein A from Provance helps eliminate packing and also can help minimize cycling associated to the Protein A chromatography. Furthermore, we looked at how using Provance Protein A can also drive this productivity while reducing costs. This includes both column costs as well as overall operational costs. By combining the high-capacity incompressible resin with a disposable hardware, we're also able to offer very flexible solutions that extend the range of sizes, allowing our customers to meet the needs of projects and products as they evolve through the drug development process. To conclude, using Provance Protein A will help you accelerate your time to market and deliver on your commitments to your customers. With that, I'd like to open it up to any questions that come up along the way.
Thank you, Kiran. And if you have any questions, please go ahead and type them into the chat window. We have one question. Is your silica treated with anything other than Protein A?
Yes, we do a surface treatment to the silica prior to the Protein A attachment. And as we mentioned earlier in the presentation, this allows the selectivity to match very closely with some of the competitive benchmarks.
And does Grace offer other silicas for larger or smaller proteins?
Yes, we offer a variety of silica-based products. We specifically sell a brand of protein purification chromatography products under the brand name Vidac, and we have been a supplier of the Vidac products for a long time.
And are you able to provide different packed bed lengths?
Our OPUS hardware collaboration with Repligen has a very unique platform, and it can particularly go a range of sizes. We looked at the diameters that go from 1.2 to 45. Our traditional bed heights go from 10 to 30 centimeters, but we're also able to offer this in custom sizes based on unique customer needs. So in any configuration between 10 to 30, we can also offer those kind of columns.
And what are the sizes that the columns come in?
The largest column we have is a 45 by 30 centimeter. This would be a 48-liter column. And the smallest one starts at a 1.2 by 10 centimeter. So there's a variety of sizes in terms of liters as well, and we can tailor it to specific operations as needed.
And how many times can we reuse the resin?
The resin can be reused depending on the sanitization conditions between 20 to up to 100 cycles. So it does depend significantly on the sanitization conditions that are used.
And is it possible, could you give a range of purity for the monoclonal antibodies tested using the Pro A column?
That is very dependent on the feed streams itself. So it's hard to provide a specific number. I think it depends on what the starting material is, what other contaminants are. So as for specific situations, we can certainly walk through if there's an identification of what that MAB actually is.
And what do you clean the columns with?
We typically recommend sanitization using an acid-based system. This would be using phosphoric acid, for example. There are other protocols as well that can be used, including sodium hydroxide for a limited number of cycling.
Is the resin base stable for sanitization and depyrogenation?
Yes, it is base stable for a limited number of cycles. So it's ideally designed for a single campaign use. So within a campaign use where the column would be used, for example, for 20 cycles followed by disposal, a caustic environment with a 0.1 normal sodium hydroxide is feasible.
Some of these are good follow-up questions, and we'll pass them along to the speaker. So if I don't get to your question, the speaker will have them and has your contact information. As a percent, how many customers are using prepackaged columns?
Actually, I'm not sure that that's something I have an answer for. I think certainly if somebody has experience with a broader marketplace, I think they might be able to better answer that question.
Okay, and a final question, and like I said, if we haven't gotten to your question, we'll pass it along to the speaker with your contact information. So the last question is, what about leachables and extractables with the column hardware?
So with our collaboration with Repligen, we provide a complete regulatory support file for any customers, and it does have a complete characterization of the leachables and extractables for the disposable hardware itself.
Okay, thank you for joining us. Thank you, Kiran. As I said, follow-up questions will be passed to the speaker, and we'll be sending you some follow-up information, including a link to the live recording that you can share with colleagues or review. Thank you so much.